Here's someone driving on the highway, another solving complex math, a man crafting poetry, and a girl mastering music. These are just a few examples of natural intelligence, demonstrating our inherent capacity to acquire and learn new skills. But we don't come into this world with all these abilities. Learning them takes time. Fortunately, nature has equipped us with the right tools. Our brains are designed to observe and process vast amounts of information. This is how we learn and become more intelligent than yesterday. The Oxford Dictionary defines intelligence as the ability to acquire and apply knowledge and skills. We don't often appreciate how sophisticated our brains are. The technological innovations created by human intelligence today look like magic compared to the tools available just a few centuries ago. One of our greatest strengths as humans is that we are tool builders. Throughout history, we have repeatedly found ways to boost our productivity. One such way involved the creation of machines. At first, such machines looked like this. This is the Gutenberg's printing press, which was invented in 1440. If we had to rank the most incredible machines of all time, the printing press would likely claim the number one spot because it revolutionized how we share knowledge. But for all its brilliance, we can't say that this is an intelligent machine, right? This device operated under fixed parameters and couldn't acquire and apply knowledge and skills. It took centuries before the notion of intelligent machines came into existence. Computer scientists, inspired by natural intelligence and human brain processes, envisioned imparting such intelligence to machines. The new field of study aimed at achieving this goal is known as artificial intelligence, or AI. Significant advancements AI scientists have made in their pursuit of artificial intelligence. In 1950, the renowned British mathematician and computer scientist Alan Turing asked, "Can machines think?" in a scientific paper. This wasn't the first time someone had asked this question, but Turing's significant contribution was to move the discussion from theoretical and philosophical to practical and experimental terms. He described an explicit criterion, later called the Turing test, for evaluating machine intelligence. In the Turing test, a human interrogator engages in a natural language conversation with one human and one machine, both hidden from view. If the interrogator cannot reliably tell the machine from the human, the machine is considered to have passed the test and exhibited human-like intelligence. This set the stage for modern computational approaches to AI, making his inquiry into "can machines think" a pivotal moment in the history of artificial intelligence. Then, in 1956, the term artificial intelligence was coined at Dartmouth Conference, and AI became a formal field of study. Participants at the conference agreed to bring together experts interested in neural networks, the theory of computation, and automata theory to explore if machines could simulate various aspects of human intelligence. As you can see, scientists have taken inspiration from human intelligence and aimed to impart it to machines from the very beginning. The AI research community has faced many challenges. The 1960s and 70s are known as the AI winter. Technology and data availability limitations reduced funding and interest in AI research. AI didn't make big headlines for decades until 1997, when IBM's Deep Blue defeated world chess champion Garry Kasparov. Computer power surged in the late 1990s and early 2000s, and the Internet rapidly expanded worldwide. Almost overnight, the necessary ingredients were in place. People worldwide were churning out massive volumes of digital data, and computer processing capabilities skyrocketed. This dramatic shift proved to be a turning point for AI research. It didn't take long before Geoffrey Hinton co-published a paper in 2006 reviving the interest in neural networks with deep learning techniques. Deep learning neural networks are a type of AI that is inspired by how the human brain works. One needs lots of data and high computational power to run deep learning models. So, creating such a model would have been impossible a decade earlier. In 2011, IBM's Watson AI won the Jeopardy quiz show, showcasing substantial advances in natural language processing. AI was able to work with human language. In 2012, researchers at Stanford and Google, including Jeff Dean and Andrew Ng, published Building High-Level Features Using Large-Scale, Unsupervised Learning, a paper that advanced multi-layer neural nets, or deep neural networks. Their system excelled at recognizing cats. In 2017, the Google Brain team developed a fundamental scientific contribution, introducing transformers. This model was a significant breakthrough in natural language processing due to its use of self-attention mechanisms, allowing it to process data sequences, like text, efficiently. Then, just a year later, in 2018, OpenAI released the first version of its GPT series. This generative AI technology utilized transformers to build massive large language models called LLMs. This led to significant enhancements across subsequent versions and introduced a user-friendly AI chat interface, or ChatGPT, in late 2022. If these terms and events seem confusing, don't worry. Everything will make sense as you progress through the course. In this course, we'll frequently talk about AI, machine learning, and data science. Sometimes it might feel as if these terms are used interchangeably, which can be confusing. Let's spend a few minutes clarifying definitions. AI claims to make machines intelligent, allowing them to learn and acquire new skills. Artificial intelligence is a broad discipline encompassing several subfields. Machine learning, one of AI's key subfields, harnesses data to predict outcomes by identifying intricate dependencies beyond mere correlations. Essentially, much like a math function, we feed input data to a model which processes the data in a certain way and produces an output. Consider this practical example. An algorithm can analyze a user's movie watching history to predict which movies they'll likely enjoy next. Similarly, a customer's financial transactions can be used to generate a credit score that forecasts their loan repayment likelihood. We'll explore various types of machine learning models later in the course. But for now, remember this definition and that ML is a significant branch of AI. And how does data science fit into the picture? Well, AI and machine learning are an essential part of data science. Every data scientist worth their salts can work with machine learning algorithms. But data scientists often use other statistical methods that are more traditional, so to say, such as data visualization and statistical inferences. Often they aim to extract insights from data without relying on ML. Therefore, data science has an essential intersection with AI and its subfield, machine learning, but also relies on math, statistics, and data visualization to gain business value from data. A data scientist can develop a sophisticated algorithm to predict future client orders, but they can also plot clients' orders against store visits and uncover valuable business insights. In our last lesson, we discussed a machine learning algorithm that predicts movie recommendations from your viewing history. We described this as a form of artificial intelligence, but we can agree that this is limited intelligence. The machine can perform a specific task that it's been designed to do. We call this type of artificial intelligence narrow AI. This type of AI is already integrated into our daily lives and has proven valuable for businesses. When OpenAI released the ChatGPT and ChatGPT 3.5 models in 2022, we saw one of the first successful attempts at creating semi-strong AI. Everyone who has tried ChatGPT knows that it can handle a wide range of tasks. It can even generate responses often indistinguishable from those a human might provide, which is what Alan Turing envisioned with his imitation game, remember? We've reached a point where an AI can successfully pass the Turing test. Today, ChatGPT can write jokes, proofread your text, recommend the best course of action, read and create pictures, create Excel and Python formulas, and solve math tasks. So, at the very least, we can call this a semi strong AI. OpenAI, Google, and other top AI research institutions have yet to achieve artificial general intelligence, AGI. Sam Altman, OpenAI's CEO, defines AGI, also referred to as strong AI, as the most powerful technology humanity has ever created. AGI will generally be more intelligent and capable than humans in several tasks. Many believe that for an AI to be considered a GI, it should be able to create science on its own. This means using all collectively available knowledge to make new discoveries and ideas. How close are we to achieving strong AI? Perhaps pretty close. Sam Altman states AGI could be developed in the reasonable, close ish future. As we edge closer to this frontier, we must consider the immense potential and ethical implications of creating machines that can think, learn, and even create science better than we do.